Hey students, this is video lesson 11B. In this lesson we're going to concentrate on direct variation, learn how to recognize it, and how to create situations with direct variation. Let's start by just defining direct variation. I'm on page 2 now, so go ahead and get to page 2. Remember, you can pause at any time to write down the notes, whatever you need. Okay, so a direct variation is a relationship between two variables that are directly proportional to each other. And in case you forgot what proportional means, proportional are where you have a relationship where the ratios between the variables are constant. So when you divide the variables, you always get the same number. All right? So now that we have those defined, let's take a look at the situation that we had previously. And it turns out that one of these situations is a direct variation and the other one is not. Let's first look at the Sunday deliveries here. On the Sunday deliveries, that's this column here, when we compare that with the hours worked. If you look at these numbers here, 150 and 1, 302, and never look at 0 when you're considering ratios, because ratio with zeros just doesn't work. But if you take 150 divided by 1, so 150 delivered 1 hour, and divide that out, you get 150. If you take 300 and 2 hours, you also get 150. If you do 450 and 3 hours, you also get 150. When that happens, you have a direct variation. So Sunday deliveries in here is a direct variation. Now let's look at the ratios created by the total deliveries. So if you look at the total deliveries here, you have 350 on the first hour. So divide that out and get 350. Then you have 500 on the second hour. When you do 500 divided by 2, you get 250. Notice those ratios aren't the same. I don't need to keep checking because the other ratios probably aren't going to be the same either. But when that happens, it's not a direct variation. You don't get constant ratios. So I'm going to go ahead and we'll look at a couple more situations and see if we can figure out whether or not they're direct variations. So I'm going to head to the next page here. And so what we were just talking about there is that the number of hours Michaela worked, I'm at the top of this page, and the number of Sunday deliveries are related. When you multiply the value of one variable by a quantity such as 230 or 150, the value of the other variable is multiplied the same quantity. That means that the number of pamphlets delivered is directly proportional to the number of hours worked. And here's that example I was showing you earlier, right here. So a linear relationship in which two variables are directly proportional is a direct variation. The equation for any direct variation can be written in the form y equals mx, where x and y are variables and m is a constant. For this one, the equation we wrote for Sunday deliveries, since it's 150 per hour, that equation would be y equals 150 times x, or 150 times the number of hours worked. Whenever you have an equation like that, that's another way to tell that it's a direct variation. Okay. The other equation for the other situation, the total number of deliveries, remember that was y equals 150x plus 350. When you get a situation like that, that's not a direct variation. Okay, so this is a direct variation. That is not. All right, let's take a look at some other problems. Let's go to the next page. Oh, I didn't see that button before. I wonder what that is. Whoa. Wasn't expecting that. All right. Oh, let's get out of that. Okay. Let's go to this page. We're on page 7 right now. And we are going to invent some situations here so you can see exactly what a direct variation is. Number 10 says invent a situation that involves an increasing linear relationship that is also direct variation. Describe the situation in words, make a table of values that can be generated. Well, since we talked about numbers being proportional for you to tell that it's a direct variation, let's start with the numbers. And remember, we can't use 0 to get equal ratios, so I'm just going to go on to the next one here. And let's say that I put a 5 here. So when I divide y by x, I would have 5 divided by 1, which is equal to 5. So for this to be a direct variation, I would need to divide 2 by some number to also get 5, and that would be 10. 10 divided by 2 is also equal to 5, and this is 15. All right? So, and if we follow this pattern, 15, 10, 5, 0 would be 0. That's another way you can tell it's a direct variation. If you have a linear situation that starts at 0, 0, where both x and y are 0, and then it's linear, which means they both go up at a constant rate, it will be a direct variation. So these always add 5, and this side we're always adding 1. And so when we divide y by x, we always get 5. That's a direct variation. All right, now we need to create the words for this situation. And what I'm thinking is, all right, so if I'm going to the store and some item costs $5, if I buy 2 items, it would cost $10. If I buy 3 items, it costs $15. So that's my situation, and I'm going to write that here. All right, so here's my situation. I'm going to the store to buy some soda for my students. The soda costs $5 for 24 pack. What would be the cost depending on how many 24 packs I buy? So if I buy 0, it will cost me $0. So this is the number of 24 packs I buy, and this is the cost in dollars. All right, so 2 packs cost me $10, 3 packs cost me $15. The equation for that would be I just need to take the dollars, which is y, I can get by just taking $5 per pack times x, which is the number of packs I buy. So for instance, if I buy 6 packs, I would do 5 times 6, which is $30. All right, now the next thing I'm going to do is graph this, and I'm going to put my x-axis, that's going to be my number of 24 packs, and on the y-axis, I'm going to have my cost in dollars. So I'm going to go ahead and make this graph. So here's my graph. 0 packs cost $0. 1 is 5, 2 is 10, 3 is 15, 4 is 20, and so on. There's a pattern there. A couple things you should notice about this graph. A graph of a direct variation will always start at 0, 0, and it'll be a straight line. So that's one way you can identify. All right, the second situation I'm going to do, we want it to involve a decreasing linear relationship that is not a direct variation. So we don't want the numbers to be proportional. And here's a situation that I made for this. If we talk about how much money I left, let's say I have $40 to buy the 24 packs of soda, how much money will I have left after my purchases? So if I buy 0 cases, 1 case, 2 case, 3 case, and so on, I'll start with $40, but every time I buy 1 more pack, I'm going to have $5 less from how much money I have. So if I buy 1 pack, I'll have $35 left. If I have 2 packs, I'll have 30, and so on. And this is not a direct variation because if you divide these numbers, y by x, 35 divided by 1, 30 divided by 2, you get different values. 35 divided by 1 is 35, 30 divided by 2 is 15, and so on. They're all different values. The equation for this would be my y, which stands for how much money I left, is equal to, since I'm going down by $5 every time,
I can still count the total I'm spending by multiplying 5 times the number of 24 packs I buy, but I'm going to put a negative in there because it's a negative on how much money I have. And 40 is how much I started with, so that equation looks like that. Notice there's something added on here. When that happens, it's not a direct variation. And here's what the graph would look like. All right, notice how this graph starts up here and goes down like that, so it's a decreasing graph, but also notice that it doesn't start at 0, 0. It is a straight line. These dots do line up, but to be a direct variation, it would have to start at 0, 0, which this one does not. All right, so that's the lesson for the day. We'll talk more about this in class tomorrow, and remember, always have these notes that you took available to help you with problems when we do them in class or when you're studying for tests. See you tomorrow.